Hey guys, today we're going to be looking at the second part of lesson 4.2 and 4.3, and we're going to focus on some proofs today. Now, we may have focused on some proofs back in chapter 3 if you were in my honors class. If you're in my CP class, this is probably your first time being exposed to what a proof is and all that it entails. So just a quick glimpse at what we're going to be talking about today. A proof is going to be a problem that has some information that is given to you. A lot of times we have a picture, and then we are asked to prove a particular statement. And the way that we're going to organize our proofs, organize our ideas, is what I call a two-column proof. That's what everybody calls a two-column proof. And we have two columns where on the left we have our statements, and on the right we have our reasons. And we'll get more into the details of how we're going to write our proofs. Now, there are 3 steps that we're going to follow for our proofs in chapter 4. And the steps are going to be: first, label the given. That's the first thing you should do, is get that given in your proof, take those easy points. Step 2, we're going to use the given / the picture or diagram that is there. And for our third and final step, we're going to find the 3. And the 3 are the 3 pieces of information that we talked about in part 1, the lesson before. That is side, 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 angle, or angle, side here. When I'm talking about proofs, while we're doing proofs, I want you to put yourself in the mindset of you're almost a lawyer, where you have this information that is given to you. You have the evidence that's from the picture, and then you have a verdict that we're trying to get, a proof that we're trying to get. And generally, as a lawyer, you know what you start with, and you know what the end result that you want is. Our job is to gather the evidence. Okay, and that's what's going to go in the middle. That evidence can be from the picture. It can be from the given a little bit. So we'll go into more details with that, but put yourself in the mindset of a lawyer. So this is the example of a proof from honors classes. We talked about this in chapter 3.5. And here you can see that we have our given, and that is written in the proof as our first step. We have our prove, which is the last step. And then our picture, along with this idea of parallel, that's the evidence that we gathered to get this particular proof completed. This is actually the proof of the triangle sum theorem from chapter 3. So here's a quick example. Everything in red is what we're going to be focusing on today. And just a quick reminder from lesson 4.1, we're going to be working with triangles. And as of right now, the only way that we can say 2 triangles are congruent is if we have all 6 pieces of information, or our 4 shortcuts. So we're going to start out with our congruent statement. The congruent statement is a good way to organize our information. So I'm going to start out with HAD. That has an angle mark of 1, 2, and 3 in that order. So we need to repeat that for our second triangle. That would be L, E, and Y would be the correct match there. And the 6 pieces of information that we know that sides HA is congruent to LE. We know that AD is congruent to EY. And we also have HD is congruent to LY. So those are our three sides. We also have the angles. We know that angle H is congruent to angle L. Angle A is congruent to angle E. And angle D is congruent to angle Y. So there's our 6 pieces of information, and we were able to use some shortcuts from our part 1 lesson that we'll be using in our proofs. Now, I want you to take a minute and make sure you have this written down in your notes somewhere. But this is really the breakdown of those 3 steps that I gave you earlier. So this is what you're going to refer to. This is sort of our template. So we always start out by labeling the given. And we will write that in our 2 columns. And we'll also make any marks in our picture. Draw anything that we need to include in our picture there. The second part is where we gather our evidence. We use the given and the picture. Now, there's a lot of terms from chapter 1 that we will be using, and even chapter 3. So we'll talk more about those as we come across them. And then finally, we're going to find our 3 things. We're looking for 3 pieces of information that will result in one of our shortcuts. If you need to pause this video to write this down, you can. I'm going to continue on with our first proof. So our first proof here, our given information is RS is congruent to UT. And we also know that RT is congruent to SU. And our reason here is that it is given. We are told that. Now I'm also going to make marks in my picture here. So RS and UT, they'll both receive 1 tick mark. RT and SU, those will both receive 2 tick marks. All right, we're moving on into gathering our evidence here. Our given, we don't have any definitions or parallel lines, so we're going to move on to our picture. And here in our picture, our 2 triangles, they share this middle side here. They share that wall. So we're going to say that ST is congruent to itself. And our reasoning here is that this is what we call reflexive. And that's it for our picture. There's nothing else that we can use here, so don't ever try to force something to be there that is not. So now we look and see if we have our 3 things. Here I have a pair of sides, a second pair of sides, and a third pair of sides. So we are able to use the shortcut side, side, side to prove that triangle RST is congruent to triangle UTS. And our reason was the side, side, side theorem. So there's our first proof. again, we're just following these steps of labeling the given, using the given or the picture, and then figuring out which 3 pieces of information that we do have. All right, for example 2. For example 2, we have our given. It says MN is equal or congruent to NO, and N is the midpoint of LP. So we're going to start out by rewriting our given. MN is congruent to NO. N is the midpoint of LP. And our reasoning is that this is given. So I'm going to make those marks MN and NO. Those are both going to receive 1 tick mark. And I see that we have the word midpoint. That is a term from chapter 1. And we know the midpoint divides a segment into 2 congruent parts. So we have N is our midpoint of this entire line, this segment. So I'm going to put 2 tick marks here. And I'm also going to write that in our picture, or in our proof, where we have LN is congruent to NP. And our reasoning here is that we use that definition of midpoint from chapter 1. So we're going to write that down as our reason. This is because of the definition of midpoint. All right. So now we're going to move on to our picture here and see if there's anything that we can determine is true from our picture. And one thing that I see is that we have this hourglass shape. And when you have this hourglass shape, we can say that the 2 angles here are congruent because they're vertical. So we're going to write that angle LNM, that's the angle on the left here, is congruent to angle PNO, that would be the angle on the right, and our reason here is that they are vertical. Again, that's another term and theorem from chapter 1. Now we've used our given, we've pulled all the information out from our picture. So let's see if we have our 3 in here. We do have, you can base this on your picture or even the information given to us. We have side angle side. We have our 2 sides and the included angle. So we can now answer the proof and say that triangle LMN is indeed congruent to PON because of side angle side. All right. And our next proof. we have that our given is AC, angle A and angle C, those are congruent. And we also know that BD bisects angle ABC. And our reason for the first step is always given. So I want to start out by writing that angle A, showing that angle A and angle C, they are congruent with some marks. So as of right now, we have a pair of angles. So that's one out of the three things that we are looking for. So we have one angle. I see this word bisects. And this was a term that we looked at in chapter 1. We know bisects. We have an angle bisector here. So this segment is bisecting our angle here, ABC at the top. So that will tell us that those two angles are congruent. So we're going to write that in our proof and show that angle ABD, the angle on the left at the top, is congruent to angle CBD, the angle on the right. And our reason is that's our definition of bisect. So right now we have two pairs of angles. So we have two pieces out of the three that we're looking for. There's no more terms, so we look at our picture and we see that we have these two triangles that are, I call these stacked, where they share a side. So we're going to say that BD is congruent to itself. Side BD is congruent to BD. And that's using that same reason from our first proof today, our first example, that is reflexive. So there's our third piece of information. We have two pairs of angles, one pair of sides. And we are able to use angle, angle, side, because that is a non-included side there. So for our fourth step, we have the information to prove that ABD, that triangle ABD, is congruent to triangle CBD. And our reasoning is angle, angle, side. And for our fourth and final proof today, we have our given information. KJ is perpendicular to JM. And NM is perpendicular to JM. So remember, that's that little symbol here, the upside down T, that stands for perpendicular. And that information is given to us. Also in our given, they tell us JL is congruent to LM. So we're going to put our tick marks there because that's something that we do know. Now we're going to use our given. So right now we're going to use this term for perpendicular. Perpendicular, we know that it forms 90-degree angles. So we have KJ is perpendicular to JM. So we have a 90-degree angle formed here at angle J, and we also have a 90-degree angle formed at angle N. So we're going to say for our second step, angle J is equal to 90, and angle M is also equal to 90. That is our definition of perpendicular. Now what we're going to do here is anytime you come across perpendicular, a lot of times you're going to use an additional step here where we're going to say, because both of those angles are 90, because J is 90 and M is 90, we're going to say that those are congruent. And that is our definition of congruent angles. So that leads us to our second piece of information. We always want things that are congruent to each other, whether it be sides or angles. So we need to include that additional step when we're using perpendicular here. Now we can look into our picture. We do have this hourglass shape. So I know that we're going to use our vertical angles here near L. So for our fourth step, we can say that J, L, K, that's the angle on the left, is congruent to M, L, N. And that is our vertical angles. And what we end up having are three pieces of information. We have two angles. We have a pair of sides. And so we are able to use angle, side, angle because we have an included side here. So we can wrap this proof up by saying KJL, triangle KJL is congruent to triangle NML. And our reasoning is the angle side angle theorem. So here are a couple of our proofs using material from chapter 1. And remember, we have our three steps: label, use the given of the picture, and then find your three. And the breakdown for each of those steps is here. If we can follow this process, this is the answer key to our proofs. We just have to know which piece we are using when it comes to the given and or the picture. All right. Guys, take a look at the practice. Complete the quizzes, homework check. And if you have any questions, you and I can get together and go over some of these proofs in a little bit more detail as needed.